Hi, today I'm going to be covering the second lesson on limits, and I'd like to start out with the limit rules. What I'm going to cover in this video are some of the basic things that your math teacher will want you to know, your calculus teacher will want you to know to progress past limits and move on to the more interesting things. But I'm going to keep it quick, and hopefully you'll find this really easy. The first thing we're going to go over the limit rules. The limit rules are, they basically state that anything you do to a function to change it will also change the limit in the same way. Now, what that means is if I take a function limit as x goes to something, it's commonly used c of f of x equals L. Now, this standard form means that for this function, as x approaches some number, like we covered in the last video, when x approaches some number, on both sides will be approaching one specific limit. Now, what the properties of limits, limit rules say, is that anything you do to this inside function, the exact same thing is going to happen to this limit. So if we use an example like this, like x squared, I'll go back and redraw this. Oop. Okay, now for the sake of this video, or for the sake of this explanation, we're just going to leave it as a regular function. So there's no empty points on here where we're going to run into any problems. Basically, I can pick a point here, and let's do f of x equals x squared. Now, so the limit, whether this point is closed or open, whether it's empty, whether it's defined or not, doesn't matter. If we want to find the limit there, we look at what's happening around it. Now, on the right side, we have it come down and it's approaching it and touches right there in the edge. And from the left side, it comes up to the same place. So now what we say is, if we add anything to this function, if we add anything to here, or we subtract or multiply, divide, anything you want to do, take it to a new power, the exact same thing will happen to this limit. And that makes sense, because if we say something like f of x equals x squared plus 5, for example, our new graph is going to look something like this. It's just going to be bumped up. So obviously this isn't the scale, but let's say around the same point, where these points are at the same x value, this one just gets bumped up 5, because the limit always has to follow what happens over here. So if I multiplied by 4, I can go ahead and draw that, just so you guys see what I'm talking about. Let's say if we get 4x squared instead, then what's going to happen to this x squared graph is it'll get boosted really quickly like this. It'll stretch out really high. But all we do is take that point that we had. This whole graph is getting multiplied by 4, so the limit has to get multiplied by 4 with it. So the limit here is 4 times whatever the original limit was over here. Now, hopefully this makes sense. So this applies for addition, and then if it applies for addition, then it must apply for subtraction. So x squared minus 5, this limit would just be shifted down 5. It works for multiplication. If I divided by 4, x squared over 4, the same thing would work. Just remember that whatever you do to this, you have to apply the same thing to your limit. And same goes for if I squared x squared, made it x to the 4th, then the limit over here, the limit would get boosted, it'd get squared. Alright, so I feel like that's a pretty good explanation of that. Please let me know if you have any trouble understanding that, but those are the limit rules, pretty simple. Now, okay, I'm going to stop this one here, and then in the next video I'll get into more actual equation solving.